everyone. So let's solve today's POTD, which is to maximum XOR for each query. First, let's understand the question. You are given a sorted array nums of n non-negative integers and an integer maximum bit, and you want to perform the following query n times. Okay. First is to find the non-negative integer k, which is smaller than 2 raised to the power maximum bit, such that nums 0 XOR, nums 1 XOR, and its XOR till its length, and its XOR with k is maximized. K is the answer to the ith query. Remove the last element from the current array nums. Return an array answer where answer I is the answer of the ith query. So let's understand this question with the help of the example, then we will understand it better. So the example given to us is a num 0, 1, 1, 3, and the maximum bit given to me is 2. So first, like, this question can be divided into two parts. The first part is to find the XOR of all the numbers, like first the XOR of 0, and then the XOR of 0 and 1, then the XOR of 0 1 1, and then XOR of 0 1 1 3. Because for the first query, we can take the XOR of all the elements, and then its XOR with the k to get the maximum XOR value. And for the second query, we have to XOR all these, like and after each operation, we have to remove the last element. Okay, so for the second query, we'll take only these three elements and remove this element, and for third query, we will take these two elements and its XOR with k, and then for the last query, we'll take this element and its XOR with k. So this question can be divided into two parts. Yeah, so these two parts are: first part is to delete the last element one by one and find the XOR of all the elements of the array. Like, we have to maintain a prefix array, and we will find XOR of each element till that index. Like, for first element we'll find for this one, and then for these two elements, and for first three, and then for all the elements like this. And in the second part, we'll find the maximum value of k, so that our result can be maximized. So let's code it up, then you will understand it better. First, let's have the size of my nums, and then find the maximum power which we till which we can get the k value, which is 2 power maximum bit minus 1. So my k value can range from 0 to e minus 1. That's why I have done this minus 1. Now first find the prefix XOR of all the numbers given to me. It will be of size n. Okay, so we know that the prefix XOR of 0, the element will be nums of 0 only. We don't have to do any change here. And then the prefix of all the ith elements starting from 1 will be prefix of I minus 1. And for the next for the prefix I, what we'll do is we'll do XOR with nums of I. So this is going to give me all the XOR of all the elements till the particular index we want. So now we'll have answer vector, which will store all the answers. Here we will start from the ending and we'll go till I is greater than equals 0, I minus minus. Why I'm starting from the ending is that because my last element, because my this prefix of the last index contains all the elements prefix. Okay, and in the question it is stated that for the first query we have to take all the elements, and for the second query we have to take like one less element from the last, like this. So we will start from the last, because for the first query I have to take all the elements. For this I'm starting my index from the last. Now what will be my maximum XOR? So my maximum XOR will be prefix of I XOR E. Now how I'm sure that I am getting my maximum element at this position only, like prefix of XOR and E? Because we are given that we are given a range of 1 to maximum bit, like 2 raised to the power the maximum bit, right? So if I do 2 raised to the power any maximum bit number like 3, 4 or 6, like if it's 3 it will give me a number which is 8. So what does that mean? It means I'll have a set bit at 8. So like this is a this E is itself a maximum number which can give me a maximum possible bit according to the XOR properties. So that's why I'm doing this, and I am getting maximum number with this prefix only. I don't have to check for each and every element till E. I am getting it uh, at the eighth position itself, which is the 2 raised to the maximum bit minus 1. So that's why I'm doing this, and then just push back into my answer. Now just return your answer, because this is what we have to return. Now let's run our code. Yeah, it's working fine. Now submit it. Yes, it's working fine. We can like if you have any doubt regarding this, like how it's giving the maximum prefix, because like if it's 2 raised to the power 3 8 and we are doing, and they said that it should be less than this 2 raised to the power maximum bit, right? So it will be 7. So if you take if like 7, for 7 we have all these set bits. For, and if it's 2 raised to the power 4 we'll get 15. For 15 we have all these set bits. So if so after getting all the set bits, if we XOR it with any number, we can maximize our answer. That's why we are just doing it with prefix raised to the prefix XOR E, and not checking for every element from 0 to E. So that's why I'm getting the correct answer. We can also check for the maximum answer, but it will be the brute force approach. The optimized approach is to XOR it with directly with the maximum 2 raised to the power maximum bit minus 1 to get the maximum, because this is the value which is going to give us the maximum result. So yeah, so here let's understand time and space complexity. Time complexity will be as we are like it will be big of n, right? Because we are uh, looping here once and then once here, so it will be big of n, and the space complexity will be big of n because we are using this prefix array. So yeah, thank you so much for watching.